Yes, ma'am.
Okay, so as I told you that calcium, strontium, and barium, they impart colors to the flame. So actually, how does it occur? So let's see. The salts of alkaline earth metals, except that of beryllium and magnesium, you have to remember that except that of beryllium and magnesium, they do not impart any color to the flame. So they produce characteristic color to the flame due to easy excitation of electrons to higher energy level. Easy excitation means if the electron is present in the lower energy level, easy excitation means if it is moved to the upper energy level. It is known as the process of excitation. Okay. So beryllium and magnesium, they do not impart any color to the flame because their excitation is not easy. They have very small size. Okay, that's why they bind their electrons more strongly. Nucleus will bind the electrons more strongly, so they possess high excitation energy and they are not excited by the energy of the flame. Whatever energy the flame is providing, that is not enough for beryllium and magnesium to get excited, right? So that's why no color is produced to the flame. So beryllium and magnesium produce no colors, calcium produce brick red, strontium produce crimson red, and barium produce apple green color in the flame. Got it?
Yes, ma'am.
Write it down.
Yes, ma'am.
With magnesium, they do not impart any color, but the color of calcium is brick red, strontium is crimson red, and barium is pale green flame. Okay. So, can you answer this question?
Ma'am, D.
Yes. Yes. Is the answer of this question?
Ma'am, C.
Yes. What is the answer of this question?
Ma'am, D.
Yes. Electropositivity increases down the. Next is your ionization energy. We'll study about the ionization energy as you know the definition. That amount of energy required to remove loosely bound electron from isolated gaseous atom. Why we are taking gaseous atom? Because we have to make sure that it is free from any other interaction. So we take gaseous atom. Now comparing it with the same procedure we are applying, comparing it with the alkali metals. So alkaline earth metals have ionization energy higher than that of alkali metals. And what about their trend in the group? So it decreases down the group. Why it decreases down the group? Because the atomic size increases. And if the atomic size increases, then the electrons would be very far away from the nucleus. So nuclear attraction becomes less. So it becomes easy to lose the outermost electron. Okay.
Yes, ma'am.
Nuclear charge means the charge on the nucleus. So if you want to write, you can.
Yes, ma'am.
Okay. So the alkaline earth metals, they possess smaller size and greater nuclear charge than the alkali metals. So the electrons are more tightly held and hence the first ionization enthalpy. First ionization enthalpy means the enthalpy which is required to remove the very first electron. Okay, it is greater than that of the alkali metal. Second ionization enthalpy means the energy required to remove the second most loosely bound electron of the second group element. It is less than the second ionization enthalpy of the first group elements. Next is non-radioactive metal of second group. They having least first ionization enthalpy is barium. Okay, we are talking about non-radioactive metal. If we say radium, then it is radioactive. It is a radioactive element. So if I ask you the non-radioactive metal of group 2 having least first ionization enthalpy is barium. So this is the order for ionization enthalpy first. Okay, for example, if I say sodium, its atomic number is 11, its configuration would be 1s2, 2s2, 2p6, right? And 3s1. Then we have magnesium, it is 12, its configuration would be 1s2, 2s2, p6, and then 3s2. So now see that if I remove this as first ionization enthalpy, this is my group 1 as you know, and this is my group 2 metal. So when I remove the first electron, then I have to remove it from 3s1, right? So it is easy to remove from 3s1. because after that it will achieve the stable noble gas configuration. But if I remove the second electron, that is your second ionization enthalpy, then it is very difficult to remove from 2p6. So now it is stable. You know that we have 3 orbitals of p. Okay, it is all filled. So it is very difficult to remove destroy the stability. So ionization enthalpy, second ionization enthalpy of group 1 metal is higher than second ionization enthalpy of group uh, group 2 metal. So it is here written that second ionization enthalpy of second group elements, it is lesser than the second ionization enthalpy of the first group element. I hope it's clear.
Yes, ma'am.
Write it down.
Yes, ma'am.
Some uses for beryllium, it is used in spacecrafts, aircraft, missiles, and X-rays. For magnesium, it is used in airplanes, missiles, flares, bombs, car engines, medicine, computers. Calcium, it is used in milk. It is used to make plaster. Okay, plaster of Paris, POP. It is your compound of calcium. It has built strong bones and teeth. Strontium, it is used in crackers. Like you can see here, the crimson red color layers to create a crimson color. Okay, so these are some uses. Now tell me the answer of this question.
Ma'am, D.
Yes, it is C, calcium. So cancer for uses for radium also, it is used in treating cancer. Uses for barium, it is used in medical applications, glass making, rat poison, and making rubber. What's the answer of this question?
Ma'am, B. B.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Yes. Okay, so this is the introduction of like physical properties of group 2 metals. Now we are going to move further to the chemical properties. Okay, so first reaction is your hydration enthalpy. Okay, hydration enthalpy means the energy released when you dissolve your alkaline earth metals into water. Okay, so here like alkali metal ions, the hydration enthalpies of alkaline earth metal ions, it decreases with increase in ionic size down the group. As the ionic size increase down the group, then their ability to dissolve in water it becomes decreases. So hydration, now compare it with the group 1 metals. Hydration enthalpies of alkaline earth metal ions, they are larger than those of alkali metal ions. So you can see that we have compounds of alkaline earth metals, they are more extensively hydrated. For example, MgCl2.6H2O, we have 6 water of crystallization here. CaCl2.6H2O, here also we have 6 water crystallization. But the alkali metals you have always seen as like NaCl only, KCl only, they do not form such hydrate. So 2 points you have to remember from this slide, that alkaline earth metal ions, they have higher hydration enthalpy as compared to alkali metal ions. And the second thing is that the trend, like if you move down the group as the ionic size increases, then your hydration enthalpy of these alkaline earth metals decreases down the group. Okay,
Yes, ma'am.
you can note it down.
Yes, ma'am.
Reactions with the dilute acids, if we see, then this M is your alkaline earth metal. When it reacts with H2SO4, which is your sulfuric acid, which is strong acid, then our products are metal sulfate. Okay, like if you have beryllium, it is beryllium sulfate. You have magnesium, it is magnesium sulfate. Plus hydrogen gas is released. When you treat your metal, that is your alkaline earth metal, with the HCl, hydrochloric acid, then you get the corresponding metal chlorides plus hydrogen gas is released. Okay, so we denote the upper arrow to denote that it is a gas. So now reactivity of alkaline earth metal, they increases on moving down the Why? Why the reactivity of alkaline earth metal increases on moving down the group? Because we have studied the electropositive character. Increase in electropositive character down the group. That's why beryllium reacts very slowly, magnesium reacts very rapidly, and calcium, strontium, barium, they react very explosively. Okay,
Yes, ma'am.
write it down.
Yes, ma'am.
Now they're reducing nature. So reducing nature, if we talk about the alkaline earth metals, then we have studied the electronic configuration. So they have 2 electrons outside the noble gas configuration. Now due to their large size and low ionization enthalpy, they can easily lose their, we are comparing it in the periodic table. In the periodic table, atomic size increases down the group and it decreases across a period. So here group 1 and group 2, they have large size and low ionization enthalpy. So they can easily lose outermost electrons. Okay, and you know that what is oxidation? Loss of electrons is oxidation. So they can easily undergo oxidation, and the substance which can undergo oxidation is known as your reducing agent. Okay, so reducing nature means their tendency to reduce other substance. Okay, so they lose electrons, 2 electrons. Okay, and the reaction is M gives you M2 plus 2 electrons. Therefore, they are acting as strong reducing agents. Strong reducing agents means that they easily reduce other substances and itself they are getting oxidized. Okay,
Yes.
write it down.
Yes, ma'am.
Now we'll see the reactions of oxides with dilute acids. Okay, so the as we know that your metallic oxides are basic in nature, metallic oxides are basic, and your non-metallic oxides are acidic. Non-metallic oxides are acidic. Okay. So, as we know that your alkaline earth metals are metals only, right? So they have basic oxides. So they can be neutralized by a dilute acid. And what is the general equation? Basic oxide plus dilute acid, it gives you salt and water. So remember, you can see that this is a type of a neutralization reaction. In neutralization reaction, what we are studying in neutralization reaction, your acid and base combine together to form salt and water. This is your acidic part, this is your basic part. They combine together to form salt and water. Okay. So this is your in solid state magnesium oxide. HCl is dissolved in water. Then we have MgCl2 ions. MgCl2 are dissolved in water. Then H2O is a liquid. Similarly, we take any acid. This is your HCl, hydrochloric acid, which is diluted. Diluted means where concentration of water is higher. Now let us take the another acid. Let us take sulfuric acid. So this is my basic oxide again. Let us take sulfuric acid. In the aqueous solution, we have the corresponding metal sulfate, MgSO4. Okay, I hope you know how to make the formula for magnesium sulfate. First, you have to write down the cationic part. Then you have to write down the anionic part. In the next line, you have to write down the valencies. As magnesium, it belongs to group 2. Its valency is 2. Sulfate, we all know that sulfate exists as SO4 2 minus, so its valency is 2. Then you just use the crisscross method, you have Mg2SO4 2. Okay, so you just, that this 2 and this 2 cancel out each other, so the formula for it will be MgSO4 plus water. Similarly, when you have to make the formula of magnesium chloride, write down magnesium, write down chlorine. Then write down the valency. For magnesium, the valency is 2. And what is the valency for chlorine?
Ma'am, 8.
For chlorine, 8. Valency means the number of electrons it can lose, gain or share to achieve stability. So tell me the atomic number for chlorine. You're having your periodic table with you?
Yeah, 1 second, ma'am. Ma'am, 17.
Yes, and tell me the electronic configuration in terms of 2 comma.
2 comma 8 comma 7.
Yes, so how many electrons it need to achieve to complete its stability?
1.
Yes, so the valency is 1. For chlorine, the valency is 1. Valency is the combining capacity of an element. That means number of electrons lost, gained or shared to achieve stability. We just use the crisscross method, then the formula comes out to be MgCl2. Okay,
Yes, ma'am.
write it down.